Right, welcome to our video. It has been quite a while and we are back with, there's a lot that has been learning. I've been trying to finish my master's degree. I've been trying to do some lab work. So that's why I've been kind of off, but we are now back. And in today's video, we are back with Rust series. And today we want to look at traits in Rust. So what are traits? So in Rust, we have certain behaviors that are demonstrated by some sort of functions or classes. And traits define shared behavior. That's what we need to memorize or to understand, that traits are here to define a behavior. And they are like a contract or a promise that this thing is going to be implemented. And who is implementing? Types. And we're going to see what that means. And we can say that you think of them as abilities or skills that different types can share, as we're going to see, that traits can be those abilities or skills that different types can share. And we're going to see what that means. They are the backbone of many Rust features like closures and operators. We've looked at closures, their functions, but with more information about their environments. If you need that video, I'm going to put it up in the top right corner. And an example here, we can demonstrate that you have different types, but they are sharing behavior. Like you have audio and video, but both of these, if you have an audio player and a video player, you can play and pause music. So that's what trait is about. It's a shared behavior shared by these types. So let's imagine that you have a group of abilities like swimming or running or cooking that people can choose to learn from. But we know that not everyone, for example, for swimming, not everyone can swim. But those who can swim, they can do floating, they can do kicking, they can do backstroking or stroking. So those who can swim, they can do different things. I mean, literally. So we know that swimming is a skill, but even within swimming, people can choose to have different types of swimming. You get what I mean? And in the world of programming, these skills are like traits. A trait defines a set of abilities or behaviors that something, which it could be a type, can choose to have. So a type can choose to have a particular element of that set of behaviors, and it implements that depending on the needs. And we note that, but itself, the trait is just a blueprint. It is not doing anything yet until someone, which is a type, decides to implement it. So we can have a trait, and until we try to implement it to model the exact behavior, it is nothing, just sitting there. And let's look at a real nice example. For example, we have these two beautiful animals. We have the dog and the cat. And we can teach these animals a certain trait. Which trait is that? For example, the trait of speaking. And we know that a dog speaks. Yes, you don't agree, it does. But how does it speak? It bows or bow, whatever, that sound. That's the trait of speaking when it comes to a dog. It speaks that language, bow. And for a cat, it also speaks. What does it speak? It speaks meow. Maybe. I hope I got it right. So when we look at these two, we look at speaking as a trait, but you can see how these two animals, the dog and the cat, are using that trait. But it's a shared behavior. They both speak. Okay, let's get into code and we model this. Okay, now we have something interesting here. From the example of the dog and the cat, we can choose to model this behavior. We are going to put our code in a single file, but we will look at another example in the next video where we look at a real world project, at least when we move to using Cargo as a package tool, for example. But that shouldn't scare you. Now, we declare, how do we define a trait in Rust? We declare a trait by the word itself, trait. So we can say trait speak, and this is there are no brackets there, and this is the trait speak. Now, within the trait that we've defined, we can choose to implement the speaking by creating a function that defines what speaking should be. And that function can take on an instance, and this instance is actualized by this word self. Now, we might choose to implement this function here in the trait, or we might choose not to, because we've said that the trait is modeled or is implemented by a type. So for us, we define the trait, and we can choose to leave it there undefined, or still a type can go ahead to implement this trait. Now, we are implementing the function speak, and we are creating an instance of speaking. Now, that means any animal like cat or dog can choose to implement the speaking in its own way. But we will pause there for that. Like, we'll stop that there. So what you need to know at this level, you have this trait speaking, and you've defined how speaking should be by creating an instance. Now we need to think about the representation of these two beautiful animals, the dog and the cat. And the best way to do that, we can choose to use a struct. And we will use a unit struct to define a dog, and we will also use the same unit struct to define a cat. We've looked at structs in our previous videos, and you can check the playlist to see what a struct is if at this level you don't know what a struct is. But at the surface level, it's a data structure that can represent behaviors or types. Yeah, that's what a struct is. So at a surface level. Now, we want to create a type that is going to implement these behaviors for the various animals that we're having here. And the best way to implement, or the way we implement types in Rust, is by using the implementation keyword imp, which means implementation, imp. I don't know how most people read it. Imp-l, or imp. I don't know. So speak. We want to implement the trait speak for the dog. And we've defined how the speak should be implemented. So we are extending, or we are overriding, we are implementing the function itself. We are not overriding it because it's not implemented. So we are implementing the function or the method speak. We have the self keyword, which means this becomes an instance method. And if you're coming from languages like Python, you've seen such methods. So how does a dog speak? We can represent that as a way of making sound by printing to screen the sound of a dog, which is bo. So we have implementation of speaking for the dog. What about speaking for the cat? We literally do the same thing. IMPL or impl speak for cat. This is capital. And we are saying the function speak takes an instance, or is we create an instance there, and we are saying that print the screen how a cat speaks, meow. We can even put an exclamation mark there. And when we go into the main function, or when we define it, function main, we want to see what comes to the screen. We can create a non-mutable variable, let dog equal to dog, our struct, and let cat equal to cat. Now, because we've implemented these structs or these types, we have access to the methods that we have implemented. So we can call the speak for every, this is let. So we can say that dog.cat, sorry, not dog.cat, dog.speak. We will see that. And then cat.speak. We now have access to the speak function, no method. So running our terminal here, we say that Rust, so we call the Rust compiler and run main. Okay, we create the binary file, and when we run the binary file, we get bow and meow. So that's how we have implemented the trait of speaking or speak for both dog and cat. We talked about the example of video and audio players where they both have a shared behavior of play, actual behaviors of play and pause. And we will look at that more in our next video. Alright guys, if you find this video useful, don't forget to subscribe, leave a like or a comment, and we'll meet in the next video. Bye bye.